Hello, this is video for class special topics on data analytics with recommender system. And we are going to learn about the next section, which is about the collaborative filtering number 2. So you already learned the pure CF. CF is the collaborative filtering. And you learn about the idea on the user base approach. So we learn about the person correlation. We also learn about the item-based approach and cosine similarity. And yeah, we also look at some problems, especially about the data sparsity. So in this section, we are going to learn those things. Okay? So we are going to look at what is memory-based and what is model-based approaches. And yeah, we are going to learn some techniques. Okay, that is the SVD. Yeah, we will learn what is SVD, association rule mining. So we already learned the basic from the previous class about association rule mining, and some other approaches like slope one, RFRAC, and etc. And we will look at the case of Google News personalization engine. And at the end, we will just have a small discussion and summary. So let's look at the details. At first, I want to explain what is memory-based and what is model-based. The memory-based approach is common in the recommender system. When we say memory-based, it means you want to use some history. You want to use some existing data. Okay, so the memory means something that you already save. Yeah, so some data that you already saved before, so it is in the memory. So the user base CF, the one that you already learned, we call this user base CF as the memory base, because the rating matrix is directly used to find neighbors or make prediction. So you still remember this kind of matrix. So this is a kind of the memory base, because we have the user and we are going to predict based on the user neighbors. It does not scale for most real world scenario. Oh, why this word appears? Does not scale. When we have a lot of people, when we have a lot of users, so this is the explanation. Large e-commerce sites have tens of millions of customers and millions of items. So it is difficult to use this kind of memory base when the number of users are so many and the number of items are so many. Okay. In this case, because the memory base, as you know, it rely heavily on simple similarity measures. So you already learned about the basic cosine similarity, the person correlation, and Jaccard coefficient, and etc. It is to match similar people, or it is to match the similar items together. If we have a huge matrix, then you know that the matrix will be about users on one dimension, and it will be about items on the other, and the cells containing votes or likes. Then memory-based techniques use similarity measures on two factors, rows or columns of such a matrix to generate a number representing similarity. As you may know that if we have a matrix, and if we want to measure the pairwise, I already explained to you on the previous lectures. If we want to use the pairwise similarity, let's say I have the n user and I have the m items, then the calculation, if we use the big O, it will be n multiplied by m. If n and m is very huge, let's say the n, the number of items, the number of user equal to m, then we have a kind of quadratic function. So we have n power of 2, like this one. Then it will be very computational cost. So the people in the domain of recommender system, they come with a new approach. They call it the model-based approaches. And it is based on the item. Yeah. Maybe you will have some question later about the items also can be so many. Yeah. But there is a little bit different with the memory base, because when we consider the item, yeah, so we just consider the particular items, not all items. And it is based on the offline pre-processing. Yeah. What is the offline pre-processing? When we want to do the model-based approach, it means I have items. I already have the items, like this one. Okay. I have the items and then I create the model. Yeah. After I create the model, then I can use that model. So we call it the model learning phase. So we create the model first. We create the model, and what you can read at this next time is we want to use the learn model. So at the runtime, only the learn model is used to make the prediction. So we create the model during the offline, or we already have the model, and then in order to predict, we just use the model. So we do not do the training. Okay. So the training can be done previously. And we can use the model updates or retrain periodically. Maybe you want to train monthly, then every month you can retrain, or maybe you want to run it weekly, monthly. Yeah, it depends on how you want to retrain the models. Yeah. And also there are lots variety of techniques used. So we can apply some metrics. We can apply some kind of probability for building the model. The model building and updating can be computationally expensive. So when we build the model, or when we do the training, and when we update the model, it is very huge. It consumes a lot of time. Yeah. So the item-based CF is an example for the model-based, because we are going to look at the items, and we just look at the items where the items already voted, or where the items already liked by the users. So some popular model-based techniques are Bayesian networks, singular value decomposition, probabilistic latent semantic analysis, or probabilistic latent semantic indexing. So those are some approaches that already popular. So if I can draw a kind of diagram to distinguish between the memory-based and the model-based, you can look at this diagram. So the collaborative filtering can have two different techniques. The first is memory-based approach, and the other is model-based approach. In the memory-based approach, it tried to find the similar users. And the similar users, it can be used with the cosine similarity. You can use person correlation and take weighted average of ratings. So we already learned how to calculate the average of ratings and etc. The advantage of this one is easy creation, and it is easy to explain the results. However, the disadvantages, as you may know, that the data can be sparse. So do you still remember what is sparse? Yes, that's correct. There are many null. There are many blank data, or there are many not available rating, right? So it is non-scalable. So you need to replace the missing values. You need to replace the nulls with some techniques. In the model-based approach, on the other hand, you can use the machine learning to find user ratings of unrated items. Oh, this is good. It means if you have a lot of data and there are many missing values, so you can use the machine learning to find what is the rating of that items. So for example, using PCA or using SVD, neural nets or matrix factorization, those are some techniques that we can use on the model-based approach. So the advantage is, we can reduce the dimension. Okay, if you learn from the data mining, we have the term dimensionality reduction. The dimensionality reduction, what is dimension? Because dimension is the column or the attributes. So in this case, we have the items. So we want to reduce the items, we want to reduce the dimension, deals with the missing or sparse data. So if there are a lot of missing data, there are a lot of sparse data, we can reduce it with the dimension reduction. And the disadvantage is the inverse is intractable. What is meaning by intractable? Sometimes we cannot explain it because it is hidden. There are some numbers are not explainable, or sometimes we call it the latent factors. Okay, latent factors, something that already built, but the number is not explainable. So later we will look at examples how to deal with this one. So this lectures, this slide will discuss more about the model-based approach. Some of them can be explained, but the numbers, the models based on the numbers like the SVD is difficult to be explained. So when we deal with this more model-based approaches, it is a plethora of different techniques. So plethora means some kind of terminologies or words. So this is a concept. So it is a concept of different techniques proposed in the early years. So when the researchers in the recommender system in the early years, or if you know, the history of this recommender system start from 2004, 2005. So they try to use the very basic approach. For example, they try to use the matrix factorization techniques, or they call it the statistics. Singular value decomposition, SVD, principal component analysis, PCA. So those are some of the techniques that we can use to produce some values. And some people try to use the association rule mining. So the comparison, you can look at the example that I already mentioned before, the shopping basket analysis. And the probabilistic models. The probabilistic models means I can use some kind of models, for example, clustering, or I can use Bayesian network, or I can use the probabilistic latent semantic analysis in order to look at the potential rating from the existing data. Or some other machine learning approaches. We can use that deep learning and other stuff. But I will discuss the basic one from this slide. What about the cost of the pre-processing? Do we need to take care about time, or do we need to take care about the memory that will be cost for this kind of approach? In the early days, they do not discuss this. And there's also some discussion how if we want to increment the model. It means after I have the model in June, I want to update in July, and I want to update again in August. So what is the updates from the model? It is not clear. So some kind of workshop, okay, in the WebKDD, they try to they try to discuss how the dimensionality reduction can be applied in the recommender system. So at the time, the discussion was how to treat more complex offline model building for faster online prediction generation. Okay, what does it mean, this one? We want to treat, this is not about the buy and sell, yeah, but we want to know if the complex offline model, okay, the complex offline model, we can use some kind of network, okay, or we can look at some numbers or the matrix factorization later with numbers. How if we have this complex model compare with the speed? Okay, we want to get the speed. So if we use the matrix factorization, whether the online prediction can be faster or not. So that's the idea from that workshop. In the first workshop, they used the singular value decomposition for dimensionality reduction of reading matrix. So the SVD, okay, we call it, this is SVD. Okay. It captures important factors or aspects and their weights in the data. And the factors, okay, what are the important factors? Yeah, the factors can be anything. For example, yeah, we can look at genre, okay, or maybe we can look at actors, or maybe directors, or maybe music, or maybe about the location that the movie taken. Okay. But also non-understandable one. Okay. Sometimes we do not know clearly about this one. Maybe it's not related with the movie directly, but maybe it is about the product that appears in the movie. Okay. So there are some kind of indicators as well that we want to capture it. So this assumption takes k dimension. K dimension here means as many as possible dimension that you can capture about the signals and filter out the noise. Yeah. So if you have a lot of features, if you have a lot of like this kind of dimension, so you can reduce it maybe until like just 220 until 100. So the result shows that it is constant time to make recommendation. Oh, what is it? It means once you build the model, and then after you have the model, you do the prediction. And when you do the online prediction, the time or the running time, it is constant. If you know, in the data structure and algorithm, we learn that constant means, yeah, you have this X, it is the time. Okay? So it means like when it is the number of data. Okay, so it is number of data, and then yeah, if the data is huge, then yeah, you can see how the time grows. But yeah, when the data is still in the reasonable size, yeah, the time is constant like this one. Then yeah, they try to use this one as one of the early model, and it becomes popular until now. So this approach also popular in IR. Okay, what is IR? Yeah, I put here IR is the information retrieval. You can use the latent semantic indexing. It can use the data compression and etc. So until now, the singular value decomposition is still useful for this recommender system. Okay, I think I will stop in this part. So we need to have more time to discuss this preliminary matrix factorization. I will discuss this one in the class, and yeah, hopefully you can do the exercise that I already gave to you previously, so you can understand how we can analyze based on the user base and the item based approaches. Thank you, and we will meet in the class.